Right. I always get excited about this. This is the interesting part. This is my favorite part. Okay. Sorry, I haven't been teaching like this for a while, so if I start jumping up and down with excitement, I apologize profusely. If I do injure my ankle, just let me call further and teach, because I've missed this way too much. I know, it's strange, but we need some excitement involved right now. Okay, right, so here we go. Converse midpoint theorem. Now, you guys learned the midpoint theorem in grade 10, and then straight after grade 10, you completely forgot about it, correct? Yeah. Don't worry, people. I'm not going to require you to prove the midpoint theorem, because most of you guys, the reason you remember the midpoint theorem so fondly, that's my sarcastic voice, is because of the proof of the midpoint theorem. You hate the proof, which I completely understand. Strangely enough, I never understood why they let you prove the midpoint theorem in grade 10, when that is pretty much one of the most difficult proofs you've ever learned. Did you ever notice that? Like the theorems that you proved in grade 11 weren't half as difficult as this particular theorem. This one was very difficult to prove. So no, we're not going to talk about proving the midpoint theorem. We're just going to recap the midpoint theorem so that you can understand this proportional division theorem. So first, the midpoint theorem states that if I take a triangle and I take the midpoint of the one side, so I go half, I take the midpoint of the other side, I go half, and I draw a line from midpoint to midpoint. What is the conclusion here? They're parallel. Absolutely. So if this is the midpoint and this is the midpoint, then DE is parallel to BC, and do you guys remember the second bit? Yes, half. This side is half the other side. Now, this theorem is not that important for us in grade 12. In fact, you could probably get away with forgetting that theorem completely. What is important to us is the converse midpoint theorem and the extension of the converse midpoint theorem. That's the important bit for us. Now, the converse midpoint theorem says, if I know that this is the midpoint, so G is the midpoint of line DE, I know it's the midpoint, and I know these two lines are parallel, what's the deduction with the converse midpoint theorem? You remember? Come on, try. What is the question? The question is, if DG is equal to GE, so I've got the midpoint on this side, and this side is parallel to that side, what's the deduction? The converse midpoint theorem says what deduction can I make? Yes, sir. Yes. It divides the other side in half. So the converse midpoint theorem then says that the deduction is that DH is then equal to HF. Now, what I need you to understand here is the following. Going back to the discussion we just had about ratios. If this is the midpoint on this side, what can you tell me about the ratio of those two sides? What's the ratio of those two sides? Yes. 1 to 1. Because the length of this side is exactly equal to the length of that side. So the ratio is 1 to 1. But what did I now say? I said this is also the midpoint. So what's the ratio on this side? What's the ratio over here? Also 1 to 1. And people, this is the proportional division theorem. The proportional division theorem. The proportional division theorem says, if I go and I take a side of a triangle, any side, and I then go and I divide it up, not into that ratio of 1 to 1. The ratio of 1 to 1 only refers to the converse midpoint theorem. I'll now go and divide it in a completely different ratio. So let's say the ratio I divide it into is a ratio of 3 to 2. So I will say this is KLM, so let's make this P. So I'll say if KP over PL is equal to 4 over 3. It's off the page, thank you. If KP over PL is equal to 4 over 3. So I've not divided it into a ratio of 1 to 1. I've divided it into a ratio of 4 to 3. then as per our previous discussion, this is then 4 times k, and this is then 3 times k. So I don't know what the exact length is. I just know I divide it into equal bits. I divide it into 7 equal bits. Do you understand? 4 of the equal bits are at the top, and 3 of the equal bits are at the bottom. But it's divided into 7 equal bits, 4, 3. Everybody got that so far? Then I go and I draw a line. And that line, very important, must be parallel to one of the 3 sides of the triangle. It's got to be parallel to one of the 3 sides of the triangle. So I'll say that means that PQ is parallel to LM. What deduction can I then make about this side? Come on. Yes, Oliver.
KG is also a KM is also a ratio of 4 over 3.
Yes.
Does that make sense?
The division of the other side is in exactly the same ratio. But now be careful. You can't tell me that this is 4k and that's 3k, because the sides are not equal. Clearly you can see this side over here, there, is much longer than this side. You understand? So you can't say that this is 4k, this is 4k, because if you say this is 4k, this is 4k, you're telling me this side is equal to that side. They're not equal. You can clearly see this side is longer than that side. So I'm not saying the lengths are equal. That's not what I'm saying. I'm saying that the ratios are equal. But since we've already used k to describe the bits that I'm dividing this side up, I need to use a different variable to describe the bits that this side is being split up in. So there I can go, for instance, and say this is 4m and this is 3m. You can't say it's k, 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 or otherwise you're going to say to me that the length of this side is the same as the length of that side, which clearly it's not. So it's not that the lengths are the same, the ratios are the same. So it's quite possible that k is going to be equal to 1. So if k is equal to 1, that means this has got a length of 4, this has got a length of 3. Everybody understands that. But it's then quite possible that m is equal to 1.5, which makes sense because this side is clearly longer than this side. So if m is equal to 1.5, then it means 4 times 1.5 is 6. So this side is going to be equal to 6, and this one is 3 times 1.5, which is going to be equal to 4.5. Do you understand? So it's not about the sides having the same length, it's about the proportion of the sides being the same. And that, people, is the proportional division theorem. So let's write it down formally. There we go, the formal theorem. And yes, I know I got there in a very cumbersome, long way, but if I just threw this theorem straight at you, I don't think you guys would have gone and said, whoa, not a clue. So I think having to do it little bit by little bit makes a lot more sense. So proportional division theorem says, a line drawn parallel to one side of a triangle, so if you draw a line that is parallel to one of the 3 sides of a triangle, then that line will divide the other 2 sides in the same proportion. That line will always divide the other 2 sides in the same proportion. So if DE is parallel to BC, then I can always make the statement that AD over DB, so the proportion of those 2 sides, is going to be equal to the proportion of those 2 sides. That's what the proportional division theorem says. Now, there are a couple of corollaries, and I think you have heard the word corollaries. Corollaries just means this theorem can be extended. And when I say can be extended, you need to understand this. So I've said that it divides it into proportion of that over that is equal to this over this. But you can also say, how about AB over AD? So we say AB over AD, and this is the part that I call the bounce. Got it? The bounce say, I bounce from A to B, I bounce from A to D. That's my bounce. The rule just says, whatever my pattern of bounce is on the one side, it's got to be the same on the other side. So if I say AB over AD, what do I have to say on the other side? AC over AE. And let's try another one. How about we go BD over AC? So if I go BD over AC, that is my bounce. What's going to be my bounce on the other side? CE over AC. And then, not going to talk about it right now, but now hopefully you guys can see why I discussed that whole cross multiplication thing. Because if I look at the cross multiplication thing, I can then also go and say, okay, so if AD over DB is equal to AE over EC, then I can make the statement that AD times EC is equal to DB times AE. So we're going to do lots and lots of little manipulations with these ratios. Got it? But it will come out in all of the examples that we're going to be doing. So when we do the examples, you can see that cross multiplication, you'll see those reciprocals, but it's important the original one that you write down must be the bounce one. So the pattern must be the same. First, Josh.
Why is C over AC? Because then wouldn't that mean that B and C are
Oh, sorry. I'm so happy you are awake, because clearly I am not. Thank you. Much better. Okay, everybody got that part so far. Now, what reason do we use when we use this theorem? We go, and there's two reasons that they accept. I will first give you my favorite one, which I prefer. As a reason, you will go and say DE parallel to BC in triangle ABC. So pretty much, you're telling them this side is parallel to that side in this triangle, so I'm allowed to use the proportional division. Got it? But a lot of people prefer this one. So the other reason, and I know Mr. Schofield loves this one, I honestly think that's longer to write than the first reason. That's why I prefer the first reason, saying this line is parallel to that line in that triangle. That's it. Got it. And obviously, if the name of the triangle and the name of the parallel lines differ, you'll just change that up depending on the diagram. Got it. It's not always going to be DE is parallel to BC in triangle ABC. It might be triangle PQR. Got it. So you'll always just say, it's this line parallel to that side in this triangle. So this is the one I prefer, but if you just write cross division theorem, that's also fine. Be careful that you don't shorten it too much and you just go crop. Okay. So be careful that you don't just do that. Right. So let's look at a very easy, straightforward example on this, and then I'll give you guys a bit of a break. Example 2 on page 6, this is in your notes. It says, in triangle ABC, DE is parallel to BC. AB is equal to 28 centimeters, so I can just put that down. This right there is equal to 28 centimeters. And AE to EC is 4 to 3. So let's write that down. So that means AE over EC, and like I said, people, this has got to be a habit with you guys. The moment you write down AE over EC is 4 over 3, never write down 4 over 3. Immediately write down Because if you write 4 and 3, you're going to make the mistaken assumption that AE is equal to 4, which it's not, and that EC is equal to 3, which it is not. Do you understand what I'm saying? So please immediately chuck a K or an L or an M or a P or a Q, some type of variable in there, just to remind you it's not equal to 4, it's the ratio. Got it? So I can then go and say this is then 4K and this is then 3K. Right. Now the question is, determine the length of BD. Determine the length of BD. So if I just immediately jump in with this proportional division theorem that I learned, we're going to start by saying that line is parallel to that line. So it divides the triangle, the two other sides, into proportion. Now I'm ideally going to go with something that helps me, meaning I'm going to do this. I'm going to go and say, because I want to calculate BD, I'm going to say BD over. And now you get to choose whatever you want. That's literally what you get to choose. So I'm not going to go BD over DA because I don't know what DA is. Do you guys agree with that? So I'm rather going to go and say BD over AB because I know what AB is. So I've done my bounce on this side. I've said BD over AB. So what is my bounce going to be on the other side? It's going to be CE, absolutely, over AC. And my reason, because obviously this is Euclidean geometry, so we require reason, is DE is parallel to BC in triangle ABC. Now I can go and I can put values in there. So I can start by saying BD is what I want, so I'll keep that BD. AB was given to me, AB is equal to 28, so I can substitute AB with 28. CE was equal to 3K. Please do not write down 3. It's not equal to 3, it's equal to 3K. That's why you need to put the K there. And what is AC equal to? 7K, absolutely. The moment you write the 4th K and the 3K down, you can totally add them together and you can say it's equal to 7K. And now we can divide those K's away. So now you can actually go and say, oh, the common multiple K and the common multiple K divides away, so I don't have to worry about it. You understand? And then I can go and say BD over 28 is then equal to 3 over 7, and now I can multiply both sides by 28. And I can say 7 goes into 28 4 times, and 3 times 4 is 12. And that is a pretty easy, straightforward example. There's other ways to do this as well. It's not the only one.
Just review why you took the K, why you were able to take the K away.
Because it's a common multiple. So K is not a variable. K is a multiple. It's a multiple of at least 1 or more. Do you understand? So because K is a constant multiple, I'm actually allowed to say K divided by K is 1. I'm allowed to divide it away. It's not a variable, it's a multiple, it's a constant. Do you understand? That's why I'm allowed to divide it away. So you guys okay with this? Good. I'm going to stop this recording.